Good morning, ladies and gentlemen. 14.4 is on multiplying and dividing rational expressions. I am not with you today because I have to work on some track stuff with Mr. Weaver. Woohoo! For the Valley meet. That's what we're working on. Anyhow, in case you were wondering, the 14.4 is going to be on multiplying and dividing rational expressions. And so I have a few notes for you to write down. Then I have 2 examples that are from the homework. Then we have some more stuff to write down. And then I have 2 more examples. So what I'm going to do is put this right about there. And what I would recommend is that the substitute teacher press the enter button now. And coming back to you, what you just wrote down for multiplying and dividing rational expressions is that it's really easier to make something smaller before you make it larger. You could multiply things out. You could FOIL some of these binomials, but I'm going to recommend that you reduce them first before you multiply. It will make your life easier. If you make something smaller, you might not have to FOIL something out. The other thing that I wrote down just way down here, whether you see it or not, it says, I prefer you leave your answers in factored form anyways. So avoid FOILing binomials because that's not even in factored form anyways. So I prefer that you don't do that in your final answers. Therefore, that's what these 3 little dots in a triangle mean. Therefore, I recommend factoring and reducing before multiplying rational expressions. You're going to see me do a lot of this. I'm going to look for things that can reduce first before I do anything else. When we reduce, it can be done top over bottom or even diagonally as long as they are groups of multiplication. What classifies as a group of multiplication? It is anything that's in parentheses. And don't forget, the fraction bar means that the numerator is in a group or in parentheses, and the denominator is in a group or in parentheses as well. And I say that because they are implied. Do not assume that it's not a group. This is it technically in parentheses. You cannot reduce the x squared and the x squared because it's in a relationship with a minus 2x minus 15. If there was an x squared minus 2x minus 15 up here, then you could reduce, but you can't because it's not the same group of multiplication. I hope that makes sense to you. We didn't have a lot on this worksheet, but we did on the last one. Look for factoring on a -1. The person who wrote your stuff, wrote your quizzes and wrote your test, the person who did that wrote it about like 10 years ago, and they really liked factoring out -1. So keep that in mind as you do your problems. Lastly, I said this already, but I prefer you leave answers in factored form, and we'll go from there. Now, I did something different because you do not have a lot of homework tonight. When I looked at how many problems you have to do, I'm only assigning you 1 section, and I am only assigning you the 9 even problems that you're supposed to do. And so what I decided to do is I decided to do number 25. I don't know if you can tell, but this actually says 25. It looks like a 26. But if you look at the other numbers that are around it, you'll see that it is 25. And this is 31. Now, these 2 problems are not assigned. As a matter of fact, these 2 problems are not assigned either, 37 nor 41. Those are the odds. And I assigned you in homework, I assigned you the evens, which means I'm giving you 2 examples of ones that are similar, but they're not in your homework. That means I would probably recommend writing them off to the side if you need to reference anything. If you want to do it on your homework paper, you can. It's up to you, but it's not a part of your homework. Sorry, I wanted you to try 9 problems. It's only 9. Be thankful. Life's good. All right, 25. The first thing is that you are going to have to decipher what numbers these things are saying. Okay, when I look at 25 and I see these numbers, I have to interpret what is this. This is 48x, and I'm pretty sure that's a 5, y to the third over y to the fourth times x squared y over 6x to the third y squared. So the quizzes and the test are going to have way better, font and graphics, or whatever you want to say, or pixelation. This is a little hard to read. And so if you think that is a 6 and you do the problem as a 6, hey, it's okay, no big deal. I just want to say that for the record, because I know some of you are going to say, well, what is that? If you don't know, you can ask on a test, but because I'm not there today, just do your best and assume what you think it is, or ask the people around you if you can't tell what you think it is, and see what they do. So here's what I'm going to do. I'm going to put all this. This is multiplying, and so I'm going to put equals 48. I'm assuming this is x to the fifth, y to the third, times x squared y over y to the fourth. We have a 6 x to the third and a y squared. And I just kind of did multiplication in any order I wanted to. Six times x to the third times y to the fourth times y squared. And the only reason I did that is just so I could start looking for things that are going to reduce. Notice that I said earlier it is easier to make things smaller before you make them larger. I think it's going to be easier for me to make the x's smaller. This is multiply, this is multiply, this is multiply, is multiply, is multiply. They're all multiplying each other. So right off the bat, I can make things smaller before I make them larger. I think the easiest thing for me to do here is I can either start reducing right away, or I can start putting things together right away. And I'm going to reduce. I'm going to say that 6 goes into 48. 48 divided by 6. 6 goes into 48 8 times. I'm going to put an 8 right here. I'm going to reduce, since there are x to the fifth, and this is multiply, and this is x to the third, and it's all multiplication. There's no plus signs or minus signs. Now I can go x to the third into x to the fifth. And what that means, since I have 3 of the x's right here, x times x times x, and up here I have x to the fifth, x times x times x times x times x. That means 3 of these will reduce with 3 of these, and you'll be left with 2 of these up here. I'm going to circle that so I don't lose it. I'm going to do the same thing with my y's. There's 3 y's up here, y times y, and that's going to reduce with 3 of the y's down there, and I'll be left with 1 of the y's right here. Don't want to lose that. I'm going to circle that just so I don't lose it. I have an x squared, and I have a y, another y squared. Here's what I'm going to do. I have 1 y right here. I have 1 y right there. Goes away. Circle this one so I don't lose it. So what do I have left? I'm looking. Gone. 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 I have a y squared on bottom. I don't want to lose that. I have an x squared here and an x squared there. I can put those together. X squared times x squared is x to the fourth power. Over. Don't forget there's a y squared in the denominator. Does anything else reduce? No. That is what I get for number 25. And that's pretty complicated, but there you go. If you can reduce, reduce. And by the way, there's really no real order to multiplication. You can multiply in any order you want to. So if you wanted to, you could have literally done like this and done that. You could have done this and then put that. You could have done this and put that. You could have even done this, x to the first, and over here and make that x to the fourth. And then you could do 6 goes into 48 8 times, and you would be left with 8x to the fourth over y to the first times y to the first is y to the second. It's the same answer. Notice, I do want you to get used to showing your work, especially on your quizzes and tests. So that's part of the reason why I tried to line some things up so I could show some work. Number 31. The problems won't always be groups of multiplications. Sometimes the problems will be these trinomials or binomials or things that you have to add or subtract. So what do we do there? You factor. That's what I would recommend. I would not avoid foiling this whole thing out. You would have to do top times the top, and that would be 3 things, another 3 things, and another 3 things. That'd be 9 terms, and that's a lot of foiling right there. Instead, let's work on factoring again. So I'm going to take this top part, and I'm going to factor it. Something that multiplies to be 10, thinking 5 and 2, but adds to be negative 3, and it needs to be a negative 10, so I'm going to need a negative and a positive. That multiplies to be negative 10, that adds to be negative 3. I believe that works for that top half right there. Over. Now I'm going to work on this bottom denominator. Going to try to factor that first. I'm going to try to make it smaller before I make it bigger. Thinking 5 and 3 again. That makes 15. I need negative 2, so probably a negative 5 and a positive 3. That would multiply to be negative 15, but add to be negative 2 times. That means this is in the numerator, by the way. Technically, this is over 1. So the denominator would be here. If I want to, I can just say multiply by. Seven and 3. 3 times 7 is 21. 3 plus 7 is 10. That looks like it works. Now we have groups of multiplication. Group is in a parenthesis. Multiplied by, and that meant multiplied by x plus 3 multiplied by x plus 7. Think of it like we just factored it down to its prime factors. That's kind of what we're doing. And so now what we can do is we can make it smaller before we make it larger. I'd say we divide. X minus 5 goes into x minus 5 one time. I'm not going to put the 1. X plus 3 goes into x plus 3 one time. I'm not going to put the 1 because 1 times anything is itself. And so what we have left here is this. X plus 2 times x plus 7. You could FOIL this out, but I told you I prefer you to leave it in its factored form. If you did FOIL it out, equals x squared plus 9x plus 14, I would also accept that. But which one's easier to write? The factored form. Which one do I prefer? This one. Why do I prefer it? Because then it shows me that you factored it, and then I could see what your factors were. I could check your factoring, and then when I'm grading and I'm giving partial credit, I'm looking at this, not looking for what kind of mistake you might have made in adding or subtracting. So I do recommend just stopping right here. And it'll make your life easier, plus mine as well. Okie dokie, those are our two examples. Lastly, the last thing I want to make sure you add to your notes is this piece right here. So what I would like for the substitute teacher to do now is to press the enter button to pause the video now. Coming back to you. Number 34 through 43, because the font's so bad, they look like they have addition signs. That's what I thought that looked like right there. I mean, look at it. Doesn't that look like a plus sign? But it's really a divided by sign. That is a divided by sign? Yes. When you copy and you copy and you copy, you lose resolution, and this starts to blend with each other. So that is really a divided by sign, even though it may look like a plus sign to all of you. Mr. Pro, that's a plus sign. No, I know. Okay? Sorry. I did not have time to retype everything this year. Patience. All you perfectionists, let it go. It's okay. So, here's what we wrote down. They look like addition signs, but they're really divided by signs. So anytime you see something like this, make sure you know this is dividing by fractions. So that's what I want you to do. When you divide dividing by a rational expression, okay? So if I'm dividing by a fraction or a rational expression, turn all division problems into multiplication problems by multiplying by the reciprocal of the divisor. What does that mean? That means if you're dividing by 2, 6 divided by 2, I don't touch 6, but what I do is I can change the division sign to multiply by the reciprocal of whatever the divisor is. Whatever I'm dividing by is what goes in, what we flip. By the way, there was an old math teacher who used to teach here, and he teaches in Sanger now, but he used to call this KFC. Keep, flip, change. So he would keep it, flip this one, and change it from a division sign to a multiplication sign. But he also liked chicken, so there you go. I don't know if that will help you to remember what you're doing when you divide, but he always said KFC, and it makes me think of the Colonel. And the Colonel. Yeah, Colonel Sanders. There you go. Lastly, then we follow the rules for multiplication. So, once again, I've picked two problems that are near or similar to the problems that you're going to do in the homework. I chose 37 and 41. I'm going to do them hopefully rather quickly. This was a divided by sign. That's a plus sign. Yeah, sweet. Sweet. Man, that looks like a divided by sign too. Okay, anyhow, here we go. 8x squared over x plus 4 divided by, but instead of divided by, I am going to change. Keep this one. I'm going to flip the second one, the divisor, to x minus 4. It's already factored for me. How nice is that? I flipped it. The denominator becomes the numerator becomes the denominator, and then I change it from a division sign to a multiplication sign. Now what reduces at this point? Okay, let's see. This is in a group. Don't forget that is in parentheses. So x plus 4, x minus 4 does not reduce. And as a matter of fact, you cannot factor out a negative, because if you do factor out a negative from here, then the x becomes negative as well. So this cannot reduce no matter what you try. They both have to be positive, or one has to be positive and one has to be negative in order for that to work. So what can reduce? Only this x and that x is what I see. I can multiply 8 times 2. which is 16x. Why do I put the x there? Because there was only one x left over. There's an x minus 4 over x plus 4. Now, whether you know this or not, this is in a relationship with that. I cannot reduce these two things. And even if I were to FOIL this in, it's still not going to reduce, because this can't reduce with that. It's not the same sign, or it's not the same group of multiplication. This is your final answer for number 37. I want to show you that if you distributed four times 16 is 64. It doesn't matter, because then if you're looking like to see what could it still reduce now, like you would factor it and you would be right back to this. The GCF is that. If this is factored form, you're going to be able to see what can reduce and what can't reduce, which is why I prefer you to leave it in this form. This just goes to show you that by going further, sometimes you might get lost, or you might make an algebraic mistake and think you can do something when you can't. This is why I prefer leaving it in its factored form. Lastly, number 41. This, by the way, is a division sign. It's a divided by problem. We cannot reduce because it's in a relationship with those things. So what I'm going to do for 41 is I'm going to factor this top piece. I'm thinking it's x minus 2, x plus 1. That works. I'm going to factor the bottom piece. X plus 5, x minus 1. Instead of divided by, I'm going to multiply by the reciprocal. So this is going to move up to the top. And at the same time, I'm going to factor out its GCF. That'll make my life easier. 5x plus 25. And then this is going to go to the bottom, which is an x minus 2. Don't forget, because it's in that bar, underneath the bar, it's in the denominator, it's in a group. It's a parentheses. So now, yep, reduce before you multiply or anything else. Reduce. Can I reduce? No. Can I factor out a -1? No. What can you do? You can leave this alone. Put the 5, the coefficient, in front when you give your final answer. 5, then parenthesis x plus 1. You can leave it in its factored form. That's what I prefer. I'm going to stop your notes right there. You have time to do some homework in class.